Let's talk a minute here about database transactions. We're about to do some coding in a checkout process where we have multiple steps that need to be completed as one unit. So think of this store's problem. Let's say that there is a customer that comes along and does a checkout, enters the ordered process, and he gets a failure notice on his computer screen. But he gets a bill in the mail because he got an order apparently. So you're going to have some angry customers if you have a halfway completed checkout process. So you can see on the right side, in your computer system, the customer was charged successfully, but there was an inventory problem and there was no product on the shelf. So you did half the process, that means you charged him. You didn't do the other half of the process, which means you mailed him the package. And so that would be a real problem. So we're trying to avoid that in our application. So here's another diagram. If we were to have a state of a transaction, we begin our state with like a complete order. The transaction part might be multiple items, like we would charge a credit card, update inventory, delete the shopping cart, create an order in the table. There might be lots of things that we do. And before we go and complete that with a commit statement, we check to see if everything's okay. If any part of the process fails, we do what's called a rollback. The transaction will fail. The customer will get a notice that says there was nothing purchased, the credit card is not bought, and so it would fail, and everyone would be okay with that. The process of making a database work reliably with multiple transactions is called the ACID process. The part that we're going to focus on is the first letter A. So an atomic transaction means that if you have a series of things that all must be completed as a group, the transactions are completed together or not at all. The other letters are important, but beyond the scope maybe of this project. Consistency means that if you have valid data in your database, people are going to get to see the correct data like they expect. Isolation means that when two people are doing a process on the same record, that one of those people gets to do the operation and does not affect the other. And so the durability, of course, is it says written data will not be lost. So we're going to focus on the letter A in this application. So here's a more wordy definition of what we just saw in the previous slide. So atomicity is the transaction involving two or more discrete pieces of information. Either all of the pieces are committed or none are. And so we'll see that in a few minutes with our code. Stating again, this is a transaction that is all or nothing. Each unit of the work must be performed in a database completely in its entirety or have no effect whatsoever. So we'll do a sample example here. For instance, let's say you are doing a transfer of a bank account, funds from one bank account to another. So if you took money out of your checking and decided that you wanted to put it into your savings, you better make sure that the deposit succeeds before you actually do the debit against one of the accounts, so you don't lose any money. So why should you care about ACID in your application design? Let's see what would happen if you don't enforce these rules of referential integrity. First of all, your data quality is bad, so you never know if your rows are what they're supposed to be. Downstream systems will not be able to use your data as well. Your application might crash, you'll have errors, and you would have some cost involved. And so if your data is corrupted, your database administrator will have to go in and fix these items manually, and your customers will be angry. So here's another example of what you might use ACID credentials for, or ACID procedures. First of all, let's say we create a new user. There are two tables to update when you create a new user. First of all, we have the users table, which includes his first name, last name, and address. And then the credentials table might have something about the password and the username, and for some reason you decide to keep those separate. You make sure that you have both tables update together or not at all, because if you have what they call auto commits turned on, your user table might get the new user, but the credentials table might not. So auto commit is a process that we're going to look at and actually turn it off when we get to our coding. So here are some good practices if you want to make sure that your data is valid. So put your transactions in our business layer. So we're going to demonstrate that in an in-class exercise as well as in the application. We don't do any transactions in our database administration object. And so we're going to use declaratives to mark the beginning and ending of a business transaction. And we will call the commit statement or rollback, either one, at the end of our process. So in the next few videos, we're going to go through a simple checking account processing system and demonstrate how the ACID procedure should work. And then later we'll come back to our application with a shopping cart, and we'll do a checkout process with an atomic transaction so that it doesn't have half a transaction. Hi, in this video we're going to look at 2 or 3 different SQL commands that are in PHP. The reason why we're looking at these is we're about to enter into an example, a tutorial, on doing atomic transactions, which means we can do multiple steps in one unit. So let's take a look at the manual here at PHP first of all. We're going to look at a command called commit, and you can see an example down the page to see what it's supposed to do. So you can see we have set this command called auto commit to false, and then they run 2 examples here of 2 SQL statements, 2 queries. Then they run the commit, and if it doesn't work, they say it failed. And so that means if either one of these does not work, then the transaction will not execute. And so we're going to be using commit and auto commit here in our upcoming tutorial. The second command that you should look up in the manual is rollback. Let's take a look at some of the examples in the rollback command. Same idea here. The auto commit statement is set to false, and then 3 statements are done in consecutive order, and then the commit statement runs. However, if something goes wrong, there is a rollback statement. So back here, we can roll back everything that we did in the previous. And so rollback cancels everything that was previously done. And so that's what you use in this upcoming tutorial as well. Okay, let's move on, and we'll show you how to use these 2 in a real life situation. In this activity, we're going to demonstrate the need for atomic transactions using the idea of ACID in our database design. So you might remember in an atomic transaction, we want to have the entire transaction either succeed or roll back and fail. So we'll demonstrate here an application that is simply adding and subtracting from 2 accounts. So I have an account here that I can start with $1,000, and the savings account is $2,000. And you can see the transaction says take take 100 out of one account and put it in the other. So every time I run this script, the accounts change by $100. Now that works great, but you can see that if half of the transaction works and half of the transaction fails, we would have a major problem. So we're going to demonstrate that with some coding here, and then we'll fix the problem later. Okay, so the first thing I want to do is set up a database. So I'm going to my PHP admin tools, and let's create a new database, and let's call it banking. How about? Banking demo is a good name for it. Inside of here we're going to create 2 tables. So I'm going to choose checking as 1, and it only needs 2 columns, and the first column is the ID number, and let's make that ID number the primary key and make it auto increment, and click go. The second column is going to be called the balance, so let's put in there a float value and click save. Now we'll do the same thing. We have a checking account. We're going to do identical with savings. So we'll create a savings account and use the ID number as the first column, and let's set it to auto increment. So for the second column we're going to call it balance again and float. So now we have 2 tables, checking and savings. Let's go put in an initial value for each of them. So in the checking account, you see I have no rows. Let's insert a row and have it as $1,000. So if we browse to it, we see row number 1 with 1,000. So our checking account is 1,000. Let's make the savings at 2,000. Okay, so we're set up and ready to go. we have some values in our databases. You can see I have a project folder called Topic 6-1 Video. And I've already set up two files here. I have the autoloader file, which is from previous projects, and the database connector, which is giving us the login name and password. So we have we got ourselves a connection. All right, so now the first thing I want to do is create some operations on these accounts. So let's create a new file, and so let's call this thing our check account data service. We're going to create a class here and then put two methods on it. So first of all, we're going to use the autoloader so we can get any classes that might be called. So let's create the class and we'll call it check account data service. We're going to make two functions, one called get balance and the other called update balance. So the update balance will allow us to modify the balance, and the update or the get balance will just simply return a value. So the first thing in this function is to get a connection to our database. The next few lines are going to actually select the value from balance and run the query. So let's check an if statement out. We'll see if there are any rows that were selected. If there are not, then we'll return a -1 as a failure. However, if a row was selected, let's get the value from that row for the column called balance, close the connection, and then return the balance as the return value for this function. And so that's the get balance. Now I'm going to create another file called tester that will see if this actually works. So inside tester, we're going to require the autoloader first. Then let's create an object for the checking account data service, and then we'll call the method for get balance and save it to the balance variable. Then we'll print it to see if we can see it on the screen. Let's go check it out to see if it actually works. So I'm going into my browser here and running tester. And sure enough, it sure looks like it works. We have initial balance of 1,000. And if I were to look in my database in the checking account, I had set that value to $1,000. So it's reading it properly. Let's return, and now we'll do the update balance command here. So we can probably copy and paste our code. So instead of selecting, we're going to delete this and change it to update. So we got ourselves an update command. Now for the return statements, a few modifications as well. So we're going to reverse the order here. So if the result comes back as any positive number, then we know that it worked. And so then the update is successful. And we'll return a 1. Otherwise, we will return a 0. And we should make a close connection as well. Okay, so now we have an update balance. Let's see if we can test it out. So after we do the initial balance, let's add some money. Okay, so we have the update command, and now we can put in a new value. So I could use the word balance here, and let's add $9,999, and then print it again. So let's take these lines here and copy them down. So we should see an increase in our balance. Okay, so this looks like the checking account's working. I'm going to duplicate this object, and we'll just make it very similar for the savings account. So I will name it as Saving Account Data Service. Let's go ahead and open that file, and then we'll just make a few modifications here. So select balance from savings instead of checking, and then the same thing at the bottom where we do an update balance. Okay, so we've made the changes here. And so as well, up at the top here, we have to change the name here from check account to saving account. And let's save that. Okay, let's go back into the tester now. Okay, so now we know all this works. I'm going to delete most of the stuff and recreate the account so that way we have a valid test from transferring one to the other. So we'll start off with the checking, and then we're going to have another variable called saving, and we'll make that a new account called savings balance data services. There we have it. So let's set two variables, one called check balance, another one called saving balance, and we will get the values from the database. All right, the next thing we need to do is print out those current balances so that the user can see what they are on the screen. All right, now I'm going to echo out my intentions. I'm going to take $100 from the checking and put it into savings. So this transaction will update the balance for the checking account by subtracting 100, and it will update the savings account by adding 100. Next, I'm going to repeat the process and show the current balance for both accounts. Let's go back into the database and reset the values so that our accounts are back to their starting values of $1,000 and $2,000. Okay, so the account balances are reset. So now let's refresh our page, and we show that $1,000 was our initial balance for checking, and it has dropped to $900. So if we keep doing this, you can see that the balance stays equal. So we have a total of $3,000 between our two accounts. So far, so good. Now, this is an example of two transactions that should be done simultaneously. If one of them were to fail, we would have a financial error. So let's come into here and make it fail. Now, there are various reasons why a transaction could fail. I could type some code wrong, or there could be an interruption in the network traffic. It would be easiest to test out the bad coding procedure. So let's say the update balance procedure for some reason doesn't work properly. I come in here and do a typo. So I put in a letter X into this statement here and save it. Now if I refresh my page, you can see that the savings balance is at $2,500 and it didn't go up. I keep pushing this button. It subtracts money from my checking account but never seems to make it to the savings account. And so we're costing our customer money every time we run the transaction. So he has far less than $2,500 now. He's down to almost $2,000. So that's not a good way to run things. So in the next video, we're going to turn these transactions into a single atomic unit that cannot be broken down. And so if one of them fails, then both transactions fail. Hi, in this video we're going to take the two account balance systems and combine them into one business service. The point of their exercise between the last video and this is to show that we need to create a series of transactions that are atomic in nature. That means they either succeed together or fail together as a group. So we're going to do some modification here. We're going to start by creating a new class, and we're going to call it Business Service. So I have Banking Business Service. Of course, the first thing we need to do is set the autoloader. So we're going to create two new functions that will be able to get the balance. So the first function will be called Get Checking Balance. The second function will be called Get Savings Balance. And then for each of these, we will return a value to the call that will tell us how much money is in this account. So we're going to utilize the check account data service. So create a new instance of it and then call the method of get balance, save it to balance, and then return it. Then we will repeat the process for the get savings balance function, and we will do the same. So far this looks pretty straightforward, but I'm going to change something now. I'm going to create the connection to the database in the business service and then use that between more than one function. Then I'm going to pass this connection object onto the method below in the data handler here. So I'm going to copy these two lines here and put in the connection here. So as you can see, I've forgotten something up here. I need to add the class statement. This is called a banking business service. And then put in my begin and end brackets. And now we have an actual class here. Now, as you remember, there is no parameter in the savings account data service. There's no constructor yet. So let's go create that. So starting with the checking data service, let's go look and see what the file looks like. So if we were to create a new function here for the constructor, we would be able to take a connection string or a connection object and create a new one here. And let's see, I also want to have a property called private here, which is the connection for our data service. So it looks like I did a mistype up here on the constructor. I need to actually say this con equals the variable connection. That means we are going to receive a connection from a higher layer in our architecture. So that means this line here, these 15 and 16, these are no longer necessary. So I'm just going to comment them out using my control / to put the comments in here, and that will eliminate this line. Now down here we're going to have another issue. It says con is no longer defined. However, we have an object called a property called con, so we're just going to sneak in the word this arrow con, and then it'll work just fine. And let's see, down here we do not want to close the database yet, so I'm going to comment these lines out. So we're handling the connection in the business layer here, or the business service. So before we are done here, we better do the connection close. So let's see, connection close. So you can see that we're taking a connection here, passing it to our object below, and then we do our work and return the balance, and then once we're done we can do the close here. What this will allow us to do is in another function we're going to have multiple statements with one connection. For right now though, I need to go and repeat this process for the other items here. So below at the update function we need to comment out some things here. So return is we're going to comment out anything that has the word connection and sneak in the word this con. So the connection string here is not correct. We should have I think it's a this connection. And down here, I forgot, we don't want to close yet, so I'm going to leave that out. Okay, so there's my model for the checking account. I'm going to repeat the entire process for the savings account. Alright, so you can see the code has lost any of the connections statements, and we're using it as a property up here. Alright, I'd like to test this out to see what the functionality looks like, see if these two methods work, the get checking and get savings. So let's go into the tester area and let's comment out most everything here just for the moment, and then we're going to add a couple of new lines. So we have checking balance and savings balance. Alright, so we're not doing any transfers yet. All we're checking is to see if we can get the balance from the account. Alright, so it looks like we're ready to go and check our testing. We're going to see if we can get the balance from each account. We're not changing anything yet. We're just checking the balance and then printing it to the screen. So I'm coming to my browser and refreshing. And it looks like it's working. So currently I have 600 in checking and 2,400 in savings. Alright, I like what I see, so I'm going to copy this line here and replace the first two lines. I'm going to delete a few more lines, uncomment these lines, and let's see, let's delete all those. Alright, so we got a line here that says we got a new service. We're going to check the balance and print it. We're going to do some transactions in the middle and then check the balance and print it again. So these two lines here are going to be different. We need to come up with a new function called transaction, and that transaction will either fail or succeed as a single function. So I'm going back into the business service and I'm going to add this function now called transaction. And I'll give it as a value called transfer as a parameter. So let's set up a connection string and then a return value, and we'll do some work in the middle. Okay, I'm going to introduce a couple of new statements. One is called auto commit. We're going to have a auto commit mode, and we are going to set it to the word false. So what that does is it delays the actual execution of a SQL statement until we call it later. So later means down here near the bottom of the function, we are going to call the connection string, and commit is the command there. So we're going to have to do some execution in between here to check to see if everything's okay before we actually run the commit. The second statement that we're going to use is called begin transaction. And so that means we're ready to start doing our adds and removes. So first of all, we need to get the balance and of the checking account and subtract 100. All right, so I'm going to create a new object called check account data service. Okay, so you can see we're passing in a connection string which was defined up here, and it looks like it's going to just use that one single connection. Now we're going to do the update here, so we're going to call the checking method here called set, or what was it called? Update balance. So now we want to take the checking balance value and subtract 100. Well, we don't actually want 100, we want to use the variable in our parameter called transfer. So I'm going to put transfer in instead of 100. Now this will return a success or failure. So I'm going to say OK checking as a new variable and assign it there. So first of all, we're going to grab the savings balance using the method in our banking service. Then we'll take a new object called savings, and using this we can get a update balance. So there you have it. We have three lines here that show we have a subtraction from the checking account, and that's the parameter transfer. Then we have a three-line group here that shows that we have an addition to the savings account by the amount transfer. Now, none of these actually happen until we check to see if both OK checking and OK savings are okay. They're true, in other words. So we can say this: if OK savings and OK checking are both true, then we're ready to go on. Both of those happen, then we can call the commit statement here. So let's go into here, copy that. And of course, if they don't succeed, if either one of them fails, then we will do a different action. We're going to call this thing rollback. So rollback will cancel any of the actions that have happened so far. Then the final thing is we close our connection. So we go here to the last line and type in close. All right, so a little bit of magic we're going through here. We are creating one connection string at the beginning of our transaction, using that same connection for both the transfer out of checking and into checking. We'll check to see if both of those are going to work, and if they do, then we should be able to run. All right, so I'm messing things up pretty bad here. So this is supposed to be not balance, but savings balance. Okay, so let's go back into our tester now, and let's implement that new transfer function. So we're going to call this thing new banking service. Got that up here. We can type in BS and transfer, transaction. And let's transaction $100. And let's see how that goes. Let's save the work, and let's go with that. Okay, run it again. Okay, so I had 500, I went to 400. This was 100, went up, so it looks like it's transferring correctly. Now the point of this test is to see if either one of these things fails, then the whole thing fails. So I'm going to have the savings account fail. I'm going to come into here where it says update balance and change the SQL statement so it doesn't work anymore. I've deleted it, or I've changed the table name, and let's intentionally sabotage it. So it should not allow any money to be taken from checking unless it is also put into savings. So, all right, so you can see as I'm running, we are not doing any transfers. So the second transfer, or second piece of the transfer, is failing on savings, which is good. We don't want to have money taken from one account unless it can be put into the other. Okay, so after I've got all of my typos fixed and the code running correctly, it looks like we've got ourselves an atomic transaction where the entire update either succeeds or fails as a group.